Good morning, students. Today, this is the third class of our online classes. So, today, here I take dielectric. So, first, let me clear you what is dielectric. You just follow the highlighted ones only. Actually, dielectric is a medium, right? You can see pure water, right? Wood, glass, etc. These all are act as a dielectric medium. Yes, this topic is also very important because we can find force. This is a force. You can see the force of a medium. I think it's very small, so let me make it little large. Is it right? This is the force of the medium. You can see, and even there are the force in the air also. So dielectric. So first, everybody please write down, if in an atom electrons are well bounded by nucleus so that it cannot escape from it, then the substance remain neutral and is called dielectric. Example, you can see pure water, wood, glass. When two charges are placed in any medium rather than the air or vacuum, then we write force of the medium is this. There is no difference between the force in the air and in the medium, but you can see a small epsilon is written here. So if it is a dielectric medium, then we will write the epsilon. Is it right? 1 by 4 pi epsilon. Whereas in the last class we have discussed 1 by 4 pi epsilon naught. Is it right? You can check 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught, the value of this 1 by 4 pi epsilon naught is 9 into 10 to the power 9 Newton meter square per coulomb square. We always write this value for epsilon naught, but if it is 1 by 4 pi epsilon, it means the force we are going to find between the two charges Q1 and Q2 is not in the air, it is in the dielectric medium. Yes, it is dielectric medium. So if it is a medium is dielectric, how we write the force? Then we write F is equal to 1 by 4 pi epsilon Q1 Q2 by R square. Okay. So on related with that, let me ask you a question. Which force is greater? Force in the vacuum or force in the medium? So first let me write force in the vacuum. Vacuum, air, free space, they all are same. How we write? Look at here. We have written here epsilon naught. Same charge Q1, Q2, same distance R square. So it is Q1, Q2 by R square. Force on the medium. Medium means once again it is a dielectric. Okay. Force on the medium. Force on the medium, it is equal to 1 by 4 pi epsilon Q1 Q2 by R square. Is it clear? Then if I divide force on the medium by force on the vacuum, then what you will get? Force on the medium divided by force on the vacuum. As usual, put both the values here. Number 1, number 2. Divide them. You will get 1 by epsilon naught by epsilon first. And let me remind you this. Epsilon naught by epsilon is nothing. It is 1 by k. So note this is also very important. Epsilon naught by epsilon is 1 by k once again. Also note that the value of k, it is the value of k here, k is nothing, it is dielectric constant. Is it clear? This is dielectric constant. Every dielectric medium has a constant value known as dielectric constant, where for one it is air, and if it is more than one, for all dielectric mediums. Once again, for air it is 1, but for all dielectric medium has greater than 1. Therefore, after divide this, we will get force on the vacuum is greater than the force on the medium. Vacuum is greater than the force on the medium. Okay, now this is one of the questions. So what we observe that force vacuum, that is air, free space, they are always greater than the any force which we are getting in the dielectric medium. Keep it in mind, very important. Several times they have asked in the CBSE board questions. This is very important. Is it right? Okay, let me take one more questions with you today so that we can solve the Coulomb's forces and all. Is it right? So here one question is there. Please write the question first. So according to the questions here, we can see the question. 2-point electric charges of values Q to Q are kept at a distance d apart in air. The third charge, capital Q, is to be kept along the same line in such a way that net force acting on Q and to Q is 0. Calculate the position of the third charge. So very simple question. There is one charge, you can see. Is it right? This is another charge 2Q. Distance between them is D. If I'll place Q in the line of joining at any position, let me take X is a distance. Here X is a distance. Then this is D minus X, because D is the distance between the two charges. Okay. So here the net force, you are going to find net force on Q and to Q is 0, it's given. So if it is given 0, that means at this charge Q and at this charge 2Q, the force is 0. Clear? So let me write this. First you have to write equilibrium. Why equilibrium at Q? Because at Q, a force produced by capital Q also and 2Q also. Once again, force produced at Q, small q, by capital Q also and 2Q also. So the net force on Q due to Q and 2Q must be 0, because it is already given 0. That's why I have written, look at your force, 1 by 4 pi epsilon naught Q, small q, capital Q, on small q due to capital Q. That's why you have written small q, capital Q. Distance is what? X. So that's why it is x square. Plus, because not only this force, 2Q is also there. Once again, plus 1 by 4 pi epsilon naught Q, because the Q is the main charge. Here I am going to find the 0 on Q only. So Q and now 2Q. Distance is D square equal to 0. Okay, is it right? And if I'll take the common 1 by 4 pi epsilon naught, I think it will become 0. You know well how to do this. Ultimately, we got capital Q a value. I don't know anything. Let me place it here as in equation number 1. Let's see. Again on the 2q it is 0. So again I have written this. Once again 1 by 4 pi epsilon naught. Now the main charge is 2q. So 2q here into capital Q and 2q with the small q. This is q. Is it right? Equal to 0. Again we get the value of this. Let me write equation number 2. After that, comparing equation 1 and 2 both. If I'll compare equation 1 and 2, q, both are q. So let me write here both are equal. From this we got this equations 2x because dd will cancel, q will cancel. I got this. Ultimately I got the value of d is this, and therefore x value is this. Here you know that rationalize, we have done the rationalization, and we got x value is 0.41 of d. So if I'll place capital Q at 0.41 d distance from small q, then I will get the 2q in 2q and in q it is 0. Thank you. Wait for the 4th class.